In this video, we are going to talk about numerical differentiation. So we have a problem that we have to construct the polynomial using the given data, x values and y values, and we have to find y dash at 1. So we have to find the derivative of y at 1, which is same as we calculate the derivative of y with respect to x, and then in the place of x we will put 1, or it is same as we calculate a derivative of the function f of x with respect to x, and then in the place of x we will put 1. So here we have to find the function f of x or y, which will be same as finding the polynomial from the given data. So we have 3 points data, x values, y values, 2, 4, 6, 0, 1, 4. So from this data we have to construct the polynomial which we are going to call f of x or y. But what method we use for construction of the polynomial depends on what kind of data we have. Is it equally spaced or it is not equally spaced? So let's check the differences between every two x values. 4 minus 2 is 2. 6 minus 4 is 2. So the difference between every two consecutive x values is same all along the data, which is 2. Here h equal to 2. This 2 is the class step. So this data is equally spaced. So we have a choice to use either forward differences method or the backward differences method. But since we need to calculate the derivative at x equal to 1 and x equal to 1 is closer to the start of x values, given x values. The x values are starting from 2 and then 4 and then 6. So the derivative needs to be found at x equal to 1, and 1 is closer to the start of the data. So we will be using the forward differences method. If derivative needed to be found at the x value which is closer to the end of x values, then we would have used backward differences method. But here we will use forward differences method to construct the polynomial. So to construct the polynomial for the 3 points data, we will first write Newton's polynomial. So for 3 data points, the maximum degree of the polynomial is 2. So we write P2 of x. This is going to be the Newton's polynomial. P2 of x equal to a naught, no factor, a1 x minus starting x value plus a2 2 factors, x minus x naught, x minus x1. We have written Newton's polynomial, but now we are going to write this polynomial in forward differences form. So a naught in forward differences operator is y naught. A1 in forward differences operator is forward y naught over h, x minus x naught. A2 in forward differences operator notation is forward square y naught over h square 2 factorial into x minus x naught into x minus x1. So we have written the Newton's polynomial in forward differences operator form. Now we are just going to find the value of forward operator y naught and forward operator square y naught by constructing the forward differences table. Let's write the x and y values. X values are 2, 4, 6, and y values are 0, 1, 4. To construct a forward differences table, first we will calculate the differences. 1 minus 0, it is 1. 4 minus 1, it is 3. Next difference will be 3 minus 1, which is 2. We have calculated the differences. Let's name the values. X0, x1, x2, y0, y1, y2. The third column is named as forward yk. Fourth column is named as forward square yk. This value will be denoted as forward y0. This value is forward y1. This value 2 is denoted as forward square y naught. Let's plug the values of forward y naught and forward square y naught in our polynomial p2 of x written in forward differences form. So we have p2 of x equal to y naught. Y naught from the table is 0 plus, this is our polynomial, forward y naught over h into x minus x naught. Forward y naught is 1 over h. H here is 2. The difference between every two consecutive x values. 4 minus 2 is 2. 6 minus 4 is 2. Forward y naught over h, which is 2. X minus x naught. X naught is 2. Plus forward square y naught over h square 2 factorial. Forward square y naught is 2 over h square. H is 2. 2 square 2 factorial into x minus x naught, which is 2, into x minus x1, which is 4. So we have the polynomial, or we are going to call it f of x, or it is y, equal to 1 over 2 x minus 2 plus 1 over 4 after simplification x minus 2 into x minus 4. We have the polynomial, but we had to find the derivative of y at x equal to 1. So let's just calculate the derivative of this function y, or the polynomial. So its derivative with respect to x will be 1 over 2 on the side. Derivative of x is 1 with respect to x, minus derivative of 2 with respect to x. 2 is the constant, its derivative is 0, plus 1 over 4. And now we have to write the derivative of x minus 2 into x minus 4. But x minus 2 is being multiplied with x minus 4, so we will apply the product rule of the derivative. What does the product rule of derivative say? First term as it is. Second term derivative. Second term is x minus 4, its derivative. Derivative of x is 1 minus derivative of 4 is 0. Plus first term derivative. Derivative of x is 1 minus derivative of 2 is 0, and the second term as it is. We have calculated the derivative of y with respect to x, which is y dash. Let's simplify the right hand side. 1 over 2 plus 1 over 4. Inside we have x minus 2 plus x minus 4. So we have y dash equal to half plus 1 by 4, 2x minus 6. We have calculated the derivative of y, or the derivative of the polynomial, and now we are going to calculate y dash at 1. This is the value of x. So in this expression y dash, put x equal to 1. We have y dash at 1 equal to half plus 1 by 4. In the place of x you put 1 minus 6. So you get y dash at 1 as half plus 1 over 4. 2 minus 6, which is 1 over 2 plus 1 over 4 minus 4. So we have y dash at 1 as 1 by 2 minus 1, which is minus 1 by 2. So the derivative of y at 1 is minus 1 by 2. Since our data was equally spaced, and the derivative of y needed to be found at x equal to 1, and 1 was closer to the start of x values, so we used forward differences method to construct the polynomial, and we got y dash at 1 equal to minus 1 by 2. So this process is called numerical differentiation process, and we use forward differences method to construct the polynomial, and then we found the derivative.